Hi guys, it's Dr. Tracy here, and we are going over this week's session of Computer Science 2, and we're talking about streams. Yeah, file streams. Super exciting stuff here, file streams. I've given you a PowerPoint, which I'm going to go over with you right now, and some reading to take a look at the input-output library and some tutorials on file streaming. So you have a discussion, and on Thursday, we'll walk through the worked example, which is the nursery text. There are some additional lab notebook programming projects to add to your growing lab notebook. So let's talk about streams. And the thing is, you've already been working with streams, and that's something that you'll be familiar with as you see, and maybe you just didn't know that's what it was called. But the ability to be able to process anything from one point to another is a stream. So the input-output library is based on the concept of streams. It allows input and it gives output so that we can talk to the computer. We've already been using it. In all of the programs that you've written, you've probably put an include statement for the input-output stream. That's because we're using the console, and we wanted to be able to access the program through the console by giving input and then produce output that will then be typed on the console. So in the same way, we are working with streams to have those input statements already included. But there's other ways to be able to have input and output besides through the console, and that's what this chapter is about. This is an example of a stream. Any kind of characters could be a stream, any kind of numbers. Anything after it would be a stream. And when you import something into a program so that it can use, whether the input comes from keyboard characters or mouse clicks or points or even audio recording, anything would be an example of a stream. That was a plain text file as a stream. It didn't have formatting or colors, but all sorts of things can be used. The stream that we have used for input to date has been CIN, which is for console in. And when you use that, it allows you to have access to the program that will read whatever is typed in at that console. You can also read whole files or whole binary information, such as image or an audio recording. To do those, you need to use a different type of stream. That's a file stream, F-stream. F-stream is a library that contains the input and output for binary files, and IF-stream is for plain text files input, OF-stream, which is obviously output file stream, for outputting plain text files. To be able to use this functionality within your program, you have to include the F-stream library. And the F-stream library is the library that has all of that functionality to be able to talk. Now, to do anything with a stream, you first need to open this stream, because you have to kind of open a connection between a file and a program, or between the console and the program, or between a microphone and a program, or whatever that you're using to collect the input. When the file is open, you refer to it by the name that it was created. Here's an example of opening streams. IF stream in file. That means that I'm going to create an input file stream and call it in file. Now I have to open it. So I created an object called InFile, and then you have to open it. InFile, open, input text. What this is going to do is it's going to create in that object, using the open method, a connection between this program and input.txt. Now, those two statements are the equivalent of the next statement, which is just put together, and that just means that IFstream infile input text is a shorthand syntax that will try to open up that file. Note here, if it's looking for input.txt, you haven't put any location or any folder there. So just by typing input.txt, input.txt for this to work would have to be in the very same location as whatever this file is. So we can also include locations if you don't want to put it in that folder, and this is the way you would use directory path information. Okay, so if the file name is going to come from the user, then you might have something that's denoted like this. Please enter a file name, creating a string called file name, and then accepting that through CN. Now creating a new file, and it says infile.open filename.cstring. Now, what that's going to do in CString will convert it will convert what you've typed in into something that can be recognizable by the computer and strip it of extra characters. So once you open a stream, there is a character in the array, and each one of those characters can be accessed individually. Now, when you are done with the file stream, the next step is to close it. And you only need to close the stream if you want to reuse the same stream variable for a different file, because it will close itself when the program ends. If you aren't opening up any other streams, they're going to be using that. So now that you have a file stream, what do you do with it? You already know how to use this because you've been doing it. It's the same syntax as with CN, which is also an input stream. So when you have an in file, now you can assign it values. You can take that object and assign it the values that you already have within your program in the same way that you would assign it to variables, as we've used in previous examples. So in this one just shows if it's not a failed condition or while there's still values, it will take those values and store it within the object. If you are trying to establish your data connection with a file stream, you also want to make sure that you don't have a failed connection, because the rest of the program won't run right unless you have something that's put into here that sort of establishes that this file stream exists. So we write to a stream in the same way that we read from a stream. And just like we have used cout, the output streams work just like the input streams, only backwards. We still create an object. We still use the open function to establish a connection, but this time it's an output connection. And you check to see if there's an error, and otherwise you send your values of your variables to the output stream. So there is a programming example in this text which uses a file that has a whole bunch of babies' names, and it's the book companion code that you can get online using babynames.txt. Now, in each one of these, the file is listed as a ranking, the name, frequency, percentage of male name in that rank, and the frequency and percentage of female name in that rank. And so each line of the file is going to have that information. In the program, to process, we first read the rank, which is going to be the first number. And so next we read the three values for that boy's name, which is name, count, and percent. So as you can see, this is assigning each one of those values to the im file. And then we read the three girls' names, doing the same. Okay, so then now we are able to talk with file stream by dealing with files individually. And this just goes over how we can use a loop control to process some or all of the files or all of the lines within the file. So here's the baby names code. And the baby names code is going to use an include statement right here that does an include of a file stream. And then it's going to read the information and print out the name. If the total is greater than or equal to 0, adjust the total. And so you can see the description here in the code. So this has a name, a count, a percent, and it's going to take each one of those lines and check for failure after each line to make sure it's not getting the wrong information or the file is not correct. And then if the total is greater than 0, because we don't want to divide by 0, it's going to output the name and the total minus the percent. So in the main section, the IF stream in file is open, babynames.txt, check for failure, and the double boy total is 50 and the double girl total is 50. So while it is greater than 0 or the girl total is greater than 0, it will read in the rank, check for failure, and process that information to the end by running the above function. So try and get that to run. See if you have any success. Let me know if you have any questions, and follow through to see if you get the correct answers. And that's a good practice set. So that's it for this one, and I'll talk to you soon.